This will be part C of number 3 from the 2014 A, B, and BC exams. And in part C here, they define some new function h of x. It depends on g, and they want us to find h prime of 3. So what I notice right away is that h of x is a quotient, and if we want h prime of 3, we're going to have to take the derivative of this quotient. So we're going to need the quotient rule. So I'm guessing how a lot of you remember the quotient rule is like this. If you have a situation where you're taking the derivative of a function of x divided by another function of x, what you can do is you can take the derivative of the top function times the original bottom function minus the original top function times the derivative of the bottom function, and then divide that by the original denominator squared. And so if we wanted to apply that to this function h here, so the g that you see, whoops, and I wrote this improperly, that's definitely supposed to be a g of x. If we want to take the derivative of h, and the g in h is different from the g that I'm just kind of generally using to state the quotient rule here. But if we want to take the derivative of h, we're going to say that h prime of x is going to be the derivative of the top function. Well, the derivative of g is going to be g prime of x. We're going to have to multiply that by the original bottom function, which is 5x. We're going to have to subtract from that the original top function, which is g of x, and then times the derivative of the bottom, and the derivative of 5x is just 5. We're going to put that all over the original denominator squared. We want to use this to evaluate h prime of 3. So we're just going to put 3's in place of all the x's. So we're looking at g prime of 3 times 5 times 3 minus g of 3 times 5 all over 5 times 3 squared. So now it's a matter of doing a little bit of arithmetic and then also figuring out what to put in place of g prime of 3 and g of 3. Well, back in part A, we actually computed g of 3. And if I click back to that real fast, in part A, we said that g of 3 was equal to 11. So I'm going to steal that from part A and get that in place of g of 3. 5 times 3 is 15 there. And then in this denominator, this is going to be 15 squared, and 15 squared should be 225. And then what is g prime of 3? So what are we going to multiply this 15 by in the leading term of the numerator? Well, if we look at this work that we did in part B, we said that g prime was equal to f of x. We used the fundamental theorem of calculus to determine that. So if g prime is equal to f, and we want to know what g prime of 3 is right here, well, that's going to be equal to f of 3. So this we can just say is going to be f of 3. What's f of 3? Well, on the graph, which is a graph of f, figure out what the y value is when x is 3. And you don't want to just jump to the conclusion that that's negative 2. It is going to be the point 3 comma negative 2, but you should do something to convince yourself of that. To get from this point to this point, you'd figure out that the slope of this line is negative 4 over 2, or negative 2. So to get from the x value of 2 to the x value of 3, in other words, have a run of 1, your rise would have to be negative 2. So to go from a y of 0 to and then do a rise of negative 2, we'd have to end up with a y value of negative 2 at that resultant point. More arithmetic. So we're looking at what? Negative 30 minus 55 in the numerator over 225. Actually, let me backtrack a little bit. I'm going to reduce a little bit right now. I'm going to divide everything by 5. So if I divide this by 5, that becomes a 3. If I divide this by 5, that's just a 1. So let's see, in the numerator I have negative 2 times 3 minus 11. That's going to be negative 17. And then if I divide this by 5, let's see, that's a pretty big one. I think if I divide 200 by 5, that should give me 40. And I guess I need 5 more than that, so I think that that's going to give me a 45. And there's your value for h prime of 3.